Hi guys. In this video, I wanted to make the connection between electric potential and the circuits that you'll be working with this week and next week, doing it in a very direct way. I mentioned it in my last video on electric potential, um, and I just wanted to just kind of recap that and summarize it. So the basic idea from last week was that electric potential describes the locations. Electric potential energy describes the actual energy between two charges and the way that they're interacting in the field. But electric potential just describes a location, just like gravitational field says, like in this area, the strength of gravity, or the strength of the gravitational field is 9.8 newtons for every kilogram. That's kind of how you should think of it. It describes a location. And an important point is that a difference in an electric potential between 2 points will cause charges to flow if there is a path that connects them. So what I was trying to show you in the previous video, you can think of electric potential in terms of kind of this topographic surface where basically a positive charge is kind of like the peak of a mountain, and a negative charge is like this sinkhole essentially, and the electric field lines will point towards that negative downhill essentially. So when you have a battery, what you have is positive charges on one end and negative charges on the other. There is this sort of barrier between them that prevents the charges from just sliding downhill. But then when you put a path between them, that's what will cause charges to flow. That'll allow the charges to flow. Now, here's an important point. In intro physics, basically, it's like a historical thing. I think it was Ben Franklin who didn't know whether it's positive charges that move from positive to negative or negative charges that move from negative to positive. He kind of just took a shot, and 50 got it wrong. So when we talk about the movement of charges, by convention, we're talking about sort of the imagined flow of positive charges moving from this end to the negative. And why do I say it's imagined? Because it's not the protons that are free to move. What we talked about in our electrostatics unit was it's the negative charges that cause this. And so the picture you should have in your battery in your head, the model is this. You have the negative end of a battery and the positive end. So you have this difference in electric potential. Visualize that difference in height, and you're seeing the charges move because there is this path. Actually, this is not the one I want to show you. This is the one I want to show you. When there's no path, sorry, when there's no continuous path, when there's this gap, that's like this high potential barrier, and it's only when you connect them that you're going to get that flow. And right here, we're showing conventional current because it starts from the positive end of the battery. This is the positive end, and this is the negative end. If you're not sure, you can just also double check with the battery. You'll see that it's labeled. Um, and an important point to make also is that electric potential, another word for that, is a voltage. So when you're saying like a 1.5 volt battery, or in our outlets, that's 120 volts, that's really just like visualize a difference in 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 height almost. And if you connect those two ends, the positive and negative end of a battery, or one end of an outlet to the other end, you're going to get charge flow. Um, and how much charge flow you get depends on what you connect. So don't ever connect both ends of an outlet directly, because you're just going to get a ton of charge flow. It's going to be dangerous. You're going to get hurt. And now, so conventional is sort of the imagined flow of positive charges, but electrons, that's what's actually moving. And they are moving from the negative end, from high potential energy to low potential energy still. But in terms of potential, it's kind of weird, because potential is defined for positive charges. You're getting negative charges that move from low potential to high potential. It still works out in terms of energy. When negative charges are all bunched together, they have high potential energy, and when they're close to positive charges, they're at lower potential energy. So you are getting this difference in energy still. But in terms of our description of high potential, it doesn't. It works less. Which brings me to the last point. When you have these, let's go with positive for a second. When you have positive charges all together bunched, it's a lot of potential energy, and when they do move here, they're losing that energy, and there's just less positive charges here. So it's almost like this peak is decreasing in height. The peak is decreasing in height, and the sinkhole is increasing in height. And so eventually that's going to get flat. So the important thing about a battery on your outlet is that it's not just a potential difference, but it's a constant potential difference. It's maintained. And as long as you maintain that potential difference, then the charges will continuously flow. And so that's where this picture is in handy. Basically, there's some mechanism inside that continues to separate the charges. In actuality, like that's like a chemistry thing. In actuality, I don't think it's actually moving it from one end to the other. I think there's like some chemical reaction that basically just continues to produce electrons, and I think the electrons over here sort of build up. So over time, you're going to get that the potential difference drops. It's not 1.5 volts continuous. It starts to decrease a little bit until the battery's dead, where that chemical reaction is used up, and it no longer can maintain that potential difference. So that's really the key summary ideas between electric potential and circuits. And so just that's like the powerful idea that helps you explain why charges move. It's electric potential and whatever mechanism is maintaining that electric potential. Hope that's helpful. Take care.